Behind closed doors in England, a team of engineers has been building something that could change flying forever. It has been kept quiet for years. But the details are finally coming out, and what is being built will catch the entire aviation world off guard. Nobody saw this coming. The project is called the UltraFan. It is the biggest engine Rolls-Royce has ever built. A test version has already been run. Now a second smaller version is being built, and this one could change how every short-haul plane in the world is powered. The first version of the engine has a fan blade diameter of 140 inches. That is the largest jet engine fan ever built. It is wider than the body of some smaller planes. Even the GE9X, which was the biggest engine before this one, has now been pushed into second place. But size is not the real story here. What makes this engine different is a gearbox sitting inside it. Most jet engines run the front fan and the inner turbines on the same shaft. They spin at the same speed. The UltraFan does not work that way. The gearbox lets the big front fans spin slowly while the turbines inside spin fast. Each part works at the speed it works best at. That one change does a lot. It cuts fuel use, it cuts noise, and it pushes the bypass ratio past 15 to 1. That means 15 times more air flows around the engine core than through it. Most of the push now comes from cool air moved by the big fan, not from burning fuel. The result is that the UltraFan burns 25% less fuel than the old Trent engines. For an airline, that is millions of dollars saved every single year. During a test in 2023, the gearbox handled 64 megawatts of power. No jet engine gearbox had ever done that before. It was a world record. And it proved the design holds together at full power. The materials are just as impressive. The fan blades are made from carbon fiber. Their front edges are wrapped in titanium, strong and light. Inside the engine, a material called ceramic matrix composite lines the hot section. It handles much higher temperatures than old metal parts. Higher temperatures mean more efficiency. More efficiency means less fuel burned. Rolls-Royce also used 3D printing to make many parts. Some shapes inside the engine cannot be made any other way. 3D printed parts are lighter and tougher than parts made the old way. Then came the surprise nobody expected. In February 2026, Rolls-Royce revealed a smaller version of the engine. They call it the UltraFan 30. It is made for narrow-body planes, the kind that fly the most routes in the world. Think the Airbus A320. Think the Boeing 737. This engine targets 30,000 pounds of thrust and burns up to 20% less fuel than engines doing those jobs today. Before we go further, if you are new here, please hit subscribe, drop a like, and leave a comment below. Now let us keep going. Rolls-Royce left the narrow-body engine market in 2012. They sold their share in the V2500 engine program and walked away. Pratt and Whitney and CFM took over that space. For more than 10 years, Rolls-Royce was completely absent from single-aisle planes. Now they are coming back. The full UltraFan 30 program will cost around £3 billion. More than £500 million have already been spent. Rolls-Royce is asking the UK government for £200 million more. They have also received €64 million from the European Union through a research project called Unified. The money is coming from multiple directions. Ground testing of the UltraFan 30 is planned for 2028. That timing is no accident. Airbus and Boeing are both studying replacements for the A320 and the Boeing 737 right now. Those next-generation narrow-body jets are expected to enter service in the late 2030s. Rolls-Royce wants to be chosen when those decisions are made. At the same time, the original big UltraFan is getting more testing done. A second build of that engine is set to run in early 2026. The 2023 test clocked around 70 hours of runtime. The next round will go further. New parts have been added. The goal is to push the engine harder and prove it can handle tougher conditions. The GE9X is worth comparing here. It powers the Boeing 777X. It holds the world record for thrust, going past 134,000 pounds during testing. Its fan was 134 inches across, the biggest in the sky before the UltraFan arrived. But the GE9X runs on a fixed shaft. The fan and turbines cannot run at separate speeds. The UltraFan does not try to beat the GE9X on raw power. The original test engine put out around 100,000 pounds of thrust. That is a strong number, but it is not a record. What Rolls-Royce is after is efficiency. The geared design can be made bigger for wide-body jets or smaller for narrow-body planes. That is the whole point of the UltraFan family. The engine is also built to run on 100% sustainable aviation fuel from day one. No changes needed. Airlines facing stricter carbon rules can use it straight away. The EU has set a target of cutting greenhouse gas emissions from short and medium-range flights by 30% compared to 2020 levels. The UltraFan 30 is aimed directly at that goal. Rolls-Royce says the full program could support 40,000 jobs in the United Kingdom and generate up to £120 billion in economic value over its lifetime. The narrow-body engine market it is targeting is worth around $1.6 trillion. There is one more thing worth knowing. The technology being developed for the UltraFan is already being added to Trent engines flying today. Better materials, better aerodynamics. Pieces of the UltraFan are already in the sky. The payoff has already begun, long before the first UltraFan-powered passenger flight ever takes off. The narrow-body engine market right now belongs to two companies, Pratt and Whitney with the GTF, CFM International with the LEAP. Both have had serious reliability problems in recent years. Both are now looking at a rival that has been quiet for over a decade and just showed up with technology neither of them has.